So looking at some of the more technical details and some of the terminology, here is a borescope, and these same terms apply to a videoscope or a fiberscope as well. Okay, I'm going to bring this one over just to have some demos. These are the easiest to kind of hold and hold up. So there's some features of a scope that are typically, important in deciding application, right? We got to fit it into an area. We've got to reach a certain depth, for instance. We have to fit through an access hole of a given size. And so what's shown here is how we determine, different types of scopes if they'll work in an area. So first off, the scope, when you are referring to parts of it, the end here that goes in to see what you're looking at is known as the distal end. Okay. The way I remember it is it's the furthest distance from my eye. The distal end is the furthest distance from my eye. Okay. And the distal end contains the objective lens. The objective lens is closest to the object that you're looking at. Okay. So you can see distal end, objective lens up there. Okay. The other important aspects I mentioned were what can it fit into. So you have what's called the working diameter. That's the diameter from the distal end to a point where the diameter increases, where you wouldn't be able to slide it into the same size hole anymore. Okay, so this one, the one I'm holding, the working diameter, right, is this part right here. The working length is how far that working diameter stays the same. So it goes from the distal end to the point where it starts to flare out or get larger. So the working length on this one is from right here to right here. If you have a borescope with a 90-degree lens, like the one shown in the image, or this one here, the working length does include that little bit that's past the objective lens. I'm losing my voice. Okay, some of the other features that we'll pay attention to on our borescopes or other scopes. I'm going to bring these back up where I can show and tell. Is we've got an overall length that includes like the eyepiece and everything. Okay, but that's really not a super important one most of the time. Again, the working length, working diameter are your two most important there, and then what direction it's looking at. Which brings me to the direction it's facing, which is known as the angle of view. So like this scope that I have here it's a 0-degree angle of view. So it's the angle if I'm looking in the end of it, I'm looking straight out. If I'm looking in the eyepiece end, I'm looking straight out the distal end. It's also known as a bottoming scope. It can look straight at the bottom of a hole. Okay, so it's a bottoming scope or a 0-degree angle of view. It has this sleeve that goes onto it. It turns that into a 90-degree angle of view. So now when I put the sleeve on, I'm either looking straight up or I can look straight down, right? But it's the angle it makes with the center line of the scope that we're looking in. Okay, so this is 90-degree, 0-degree. This little or skinnier scope that I've got, this is a 90-degree angle of view. So you look down the end of it and kind of the center of your view is straight up or straight down, it's 90 degrees to the center line. There are scopes with other angles. We'll look at the types of angles as well. The other thing we want to pay attention to in these scopes is what's known as the field of view. And that is when you look out the end of this, how wide, what angle, if you look from the full left to full right side of the image, how wide is that angle? You can have a narrower angle of view, or you can have a wider angle of view. Some scopes go upwards of 180 degrees. Most scopes are somewhere in the 30 to 60-degree range. Okay, a narrower angle of view or field of view, narrower field of view tends to have a little bit more magnification. You can see stuff further away, but obviously you can't see. You don't have as much peripheral vision. So angle of view, direction compared to which way you're looking, where the center line of the scope is. Field of view, how wide is that view that you're seeing? How many degrees from left to right or top to bottom, or that kind of thing. Here's just kind of some pictures of that construction. So this is a scope very similar to the one in my hand, where we have an objective lens at the end. and it can be a prism in some cases. This one happens to use a lens. This actually has this is a prismatic. This has a prismatic or a prism lens on the end of it, the skinnier scope that we have. And then the glass fibers running up alongside of the various lenses along the length that transmit the image to the eyepiece, and then the eyepiece. One of the reasons these light cables, why they went to fiber, and I kind of mentioned this with the video scopes and the difference between our kind of professional model and the ones that we just got off Amazon. By having these light sources external from the scope, you don't have a ignition risk at the tip like you do with a light bulb. So again, it has to deal with if you're going into an area where there's potential for an explosive or combustible atmosphere, having the, enclosed inside of like a fuel tank or an oil containment of some kind, having the light source run through fiber optics, you're not going to risk sending electricity up to a bulb or producing heat with an old filament type bulb like you would have in that little scope here, where the risk is probably pretty low, but you still are running electricity up here, and there still is a little filament in the end that's going to be hot and produce that light. Here's the fiber scope inside. It's showing the two bundles of fibers. So one going from the light source out to the tip to provide light, one going from the tip back to the eyepiece in order to transmit the image. This also running alongside something like this, if it has the capability to articulate, that is going to have cables running along the sides of it. And that does bring me back real quick on this. So if we have one of these articulating scopes, what is the angle of view on this scope? It's 0. What is the angle of view on this scope? It is still 0. Okay? The angle of view is the relation with the lens, okay, on the articulating part. What you have is an articulation angle, which is in addition to what's shown on the screen here. So this scope can articulate 180 degrees, okay, but it's still a 0 degree or bottoming scope. Okay, same thing with our other video scope, and same thing with our fiber scope. Yeah. What would be the what? Not for these. Maybe a little bit when you calculate an angle of view in a field of view, primitive field of view. Where you'll use math when we get to infrared thermography, you're going to have to calculate pixel size, which requires trigonometry. You're taking calculus here. Trigonometry is a couple levels below that. It's been a while, yeah. You should be good. I'll walk you through that process when we get to it. But so trigonometry is probably about the highest level, maybe a little geometry here and there. You got trigonometry covered. And if you know SOHCAHTOA, you're good to go. Off topic for what we're discussing now. Here's the inside of a video scope showing the housing, the protective sheathing. This does show the articulation cables, the fiber optic bundles, right, for that articulated end. Again, 0 degree angle of view. It's going to have some kind of a field of view, typically somewhere between 30 and 60 degrees. And then articulation is a separate measurement from angle of view. Okay. So articulation is how far it can bend. So like this one may be up on the board. If that's as far as it'll go, it would have a 45 degree, maybe 60 degree articulation, something like that. The light sources you saw, here's the different examples of LEDs in the tip. They can have a single LED or several. Sometimes they surround the camera. Sometimes they're off to one side, like what those have. And the next thing I'm going to do, I want to show you a video of kind of the next step up from the Olympus video scope. It's another model that you'll see out in industry more.